All right. Hello. We're waiting. We'll wait a couple seconds for people to jump on. Um, I see some people doing so now. Welcome. This is another stream that we're gonna do with a super special guest today. Um, so first off, I'm Dino, and I'm like kind of stalling so more people can jump on. But I'm Dino, one of the co-founders of Fluent, here with Steph, COO at Fluent, and a very special guest, Mr. Nayrolf, G Blend, my friend, one of like the best in the game at making complex topics, putting complex topics into simple words. And I think that's the goal here for today. So welcome, man. I'm gonna pass the mic to you. I know you're gonna run the show and ask us some questions. So go for it.
Hey, good morning. Or should I say G Blend? No, thanks for having me. So, as you just said, my concept on Twitter is just to put really simple words on complex topic, and I guess it's what we gonna do today with blended execution. So, I will start, bro. What is blended execution?
All right. I'll kick this off and then Steph can chime in. We'll just make this casual and go back and forth for each of these questions. Blended execution. Um, in the simplest way possible, I would say blended execution is this idea that in one blockchain, like one execution environment, um, typically the EVM is an example of an execution environment. Well, sorry, actually, I'll skip over the difference between kind of like VMs and execution environments. Just picture like a blockchain where you run your smart contracts. And in most blockchains that are not blended execution environments, you can typically only run a limited set of like apps or smart contracts. You can in the EVM, most of the EVM chains, you can deploy things in contracts in Solidity, and you can code in Solidity and Viper and but mostly Solidity. Um, and in some of the other like alt VMs that are popping up, they offer other types of languages. So you might be familiar with SVM, MoveVM, etc. They're novel because they offer something that's different from the EVM, but they're still constrained within like their set of tools and building blocks that they offer. So for MoveVM, it's Move. For SVM, it happens to be Rust. And so this idea of blended execution is you can have an execution environment, a blockchain, that lets you take apps from a lot of these different environments and literally just like run them in the same place. So you can copy paste apps from EVM chains, copy paste apps from SVN chains, and take a bunch of languages from Web 2 and code in those languages like Rust and C++ and languages that people know outside of the blockchain space, and literally just have one sandbox, nice and easy for a developer to like use all the best tools. And we think the reason this matters is because when you give developers all of those tools to just easily kind of plug and play, you end up with really amazing products. So that's my attempt, Steph. I don't know if you want to give it a shot, but
No, I was just going to say, like, you covered it from my perspective, and you did a far better job than me because I would have gone way too technical with it. But yeah, I think it's just like, just to tie that all off, it's kind of like an arbitrary execution environment, and the idea is that it's extensible. So for the Fluent L2, it'll be EVM apps, SVM apps, as well as WASM-based apps. So those traditional programming languages from Web 2. However, the framework that we're building will enable you to build your own blended execution networks, which could enable different languages as well. So the design is not strictly limited to those three. It can go to MoveVM, it can go to FuelVM, which we're actively integrating, and really keep going from there. I'll pause there.
Okay, that makes sense. So that's very interesting. Um, so you explained this like notion of execution environment, and you also explained that blended execution is putting like a bit like putting all those different virtual machines into the same execution environment. Am I wrong here, or like am I right? Like, is it a bit this, or is it something different? So is it still a single virtual machine, or are there, let's say, multiple virtual machines all coexisting in the same execution environment?
So yeah, okay, this will probably be the most technical we go for the show, but I'll try to keep it light. But effectively, Fluent Solution is in fact one virtual machine, but it simulates the other virtual machine that it supports. And the reason why this is important is because it's a distinct solution from multi-VM, which, as you know, is a blockchain or blockchains that support multiple virtual machines in parallel and enable some kind of communication between them. So with Fluent Solution, it's one virtual machine, which is the RWASM virtual machine, or the Fluent VM, you can call it. And it effectively creates this sandbox in which it simulates the logic of the other virtual machines. But in reality, it's just one underneath that does all of the different logic, and the state transition function is of that one virtual machine.
Okay,
maybe make that a little bit easier to understand.
No. I think that was good. I think the main different, or sorry, like the main thing that we want to emphasize is the way in which that Fluent supports apps from these different environments is by like not actually running the virtual machines from those like it's not literally running EVM. It's not literally running SVM. It's not literally running any other VM except for the one that Steph just mentioned. What it's doing instead is simulating those VMs. And so even that, you might say, like, what does that mean? But the way you can, like, that can get very technical, and there's a lot of different like low level innovations that get put together to make that happen. But the way you can like easily conceptualize that is there are certain, there's a certain number of like standards, right, associated with each of these virtual machines. So you might be familiar with like EIPs, right? Like there's a ton of EIPs. Those are different like standards that are being implemented into the Ethereum virtual machine specifically. And like what we're simulating is like, these standards and different like checks that are done for those protocols. So think of like these, think of like parts of the Fluent execution environment, these like low level these like basically smart contracts. Think of smart contracts that are just sitting there that are like part of the system. So they come like pre-packaged with Fluent's execution environment that are like making sure as the apps are talking to each other that couldn't previously talk to each other on any other environment are these special system contracts are like making sure the checks and balances are okay. It's kind of translating like, one thing to another in a way, but like the point is that the user doesn't have to think about that at all. Like it's all done. It's abstracted away, done behind the scenes. It's just kind of like part of the system.
Okay, that's super interesting. And now you just mentioned that those apps that weren't able to communicate between each other before are now able to communicate between themselves. So it means that, well, developers, if we put ourselves into their shoes, they can just build application in multiple languages at once, right? So I guess like the key point is that a single application can just blend, or let's say leverage different programming languages for different part of their application. If I get that right. But then, like, why would a developer, for example, build a blended application instead of a non-blended application, let's say?
Dean, I'll let you take this one. I know you got a great answer.
Okay, yeah. So the reason why this all matters, at least in our opinion, is like think about all of the like I'll try to make it simple as possible. So like think about all of these different languages from these different VMs and all of the smart contracts that people have built in these different VMs and the different like software libraries that correspond with each of the different languages, right? Because just quick note, for each language, there's sometimes like hundreds of thousands or even like millions of software libraries that you can think of as like building blocks that are coming hand in hand with these languages. So when you think about all that, right, you think of like different languages, each of the millions of building blocks that are coming with those languages, that is basically pre-written software that you don't have to write. You could just take off the shelf and use for your application. And then like even just at a higher level, like the actual smart contracts and apps that have been written for those blockchains using those languages and building blocks, right? So think of all of that as just like tools that could be in a developer's sandbox to build with. Like it's all really all building blocks, like all the way down. Like, and so when when you make this like maximally expressive environment for developers to come in and pick from any of those building blocks and just take them all off the shelf, they can build things that first off they just like simply couldn't build before on other chains. And the things that they could build before on other chains, they could build those things faster, most likely, because you're able to just like take pieces. It's modularity in a way. It's just like a finer grain modularity where you're able to take like these building blocks and just like iterate on them very quickly. And then, you know, to some degree, you can actually, even if it's just one-to-one, the same type of application, you can, it's most likely it'll be more performant too, because like, you know, you might be like implementing the logic in a language that's much more efficient, such as C++ over, you know, over TypeScript, or C++ over Solidity. So I think that's, in our opinion, like why it matters. And so when you put like more of these, when you give developers all of these tools to use, like typically you end up with better products. And that's what we've seen over the course of like all development paradigms.
Yeah, no, I'll just second that with a little more color. Dino did a talk at the Modular Summit about how your favorite apps are blended. How, in fact, when you look at like the real world, or sorry, I don't mean to say that blockchain is not the real world, but zooming out a little bit and you look at the Web 2 world, like apps are composed of, you know, many different types of like subcomponents that are written in different languages, right? Like the microservices architecture enables you to have like a portion written in C++, a portion written in TypeScript, a portion written in, you know, whatever logic makes sense for that part of your application. So what we're trying to do is bring that kind of expressivity and environment to the Web3 context as well. So I guess a good example of this is just like, at the end of the day, right, the virtual machine is the RWASM virtual machine, or the reduced WASM virtual machine. And so it has efficiency improvements over the standard EVM. And so even though you're able to like simulate, you know, EVM or Solidity smart contracts, at the end of the day, you are benefiting from that efficiency of the WASM-based virtual machine that is supporting the entire system. So you're able to, you know, use a portion of your app in Rust, so a Rust engine that otherwise wouldn't make sense to write and run in Solidity, and you're able to do that in addition to adding logic in Solidity type languages. So imagine like an ERC20 token, and so you can have some kind of application or a game, and I think we'll get into that a little bit later on, that has these advanced properties written in Rust or otherwise, but then also could take advantage of the economics of using ERC20 tokens. I'll pause there, and I guess we can get into that a bit later on as well.
Super interesting. So like if I rephrase a bit, you allow basically developers to divide their application in certain like components, and then like for each component they are able to just like take the best tool to just like develop this component. So let's say they want to build a complex algorithm that will necessitate complex let's say computation afterward. They will just use, for example, Rust, because it might be a language that is suited for this use case, right? That totally
Exactly.
That totally makes sense. Okay, so I guess now we have talked a lot about developers, so maybe we can just like put ourselves in the shoes of users, because I know a lot of my audience are basically users that are eager to just like test this blended execution design. So what does that mean for users basically? So you mentioned that well, the EVM or Solidity can just like coexist or communicate with WASM or Rust, for example. But you know, let's say I'm still a bit old school, right? And I like MetaMask, right? I don't want to install another wallet, let's say. But like, will I be able to interact with, let's say, Rust application? Because now if I want to go with my MetaMask wallet on Solana, for example, that basically won't work. Or if I want to go like on Cosmos, I will have to install another wallet. Like, how you know, like what will happen for the user? Do you have maybe an example to just like explain us?
Yeah, so we're building the system in such a way that all of the complexities of what's happening under the hood is, you know, both abstracted to a large degree from the developer, but also from the user. So as a user, you may not be aware of, what programming languages or, what type of contracts were used to like service the application that you're using, like you will be able to access it from your MetaMask wallet. It's going to be EVM compatible in that way. And so it really doesn't matter what's happening under the hood from your perspective. It should feel exactly the same way as just interacting with Ethereum, maybe a bit faster and more efficient. But other than that, you wouldn't know.
Yeah. Yeah, exactly. So, and again, just to emphasize, like even the chess game example, right? They're just thinking about the alternative universes in which like this didn't exist. Maybe that chess game wouldn't exist, just hypothetically. Like this is just an example. And you probably could implement it like otherwise, but the fact that there are some applications, there are some like functions, there's some kind of like types of cryptography, there's some like a bunch of like mathematical operations that just won't be feasible to run like on a roll up in a language like Solidity. And so therefore, like there are a bunch of applications that require those types of components, even if it's just for a part of the application, that just like wouldn't exist. So like as a user, it's literally just like enabling new types of apps, and hopefully, like we were kind of alluding to before, enabling apps at kind of like a faster development cycle, just because you are able to just like leverage a bunch of things that you don't have to build and really just specialize on like the logic that makes the most sense for your application or is most unique to your audience.
Thank you. So you mentioned a bit a chess game, right? I think I've seen this demo on Twitter. I think I've even like tested it, and it worked quite nicely. So is that the first blended app? What were the feedback from developers, from users? From my experience, it worked smoothly, but like, what was a bit like the essence of this first blended application?
Yeah, so the chess game was one of the first applications to be developed on like Fluent's public DevNet. So we're now in public DevNet, meaning that developers, it's open and permissionless for anyone to deploy Rust and Solidity apps and create blended applications that mix the two. But as we launched that, our team in-house was able to make a demo application, which is a chess game. So a portion of the game is written in Rust. So the actual logic of how the chess game functions, if you win, if you don't, is written in Rust. And going back to the ERC20 example, whether you make it a correct move, so whether you win or lose, the user is credited in ERC20 tokens, test ERC20 tokens. It's still on testnet. But so the contracts are able to directly call each other. The Rust contract sees if the user in fact did win a game, and then calls the ERC20 token contract to then go and increase their rewards or decrease their rewards based on whether they won or lost. Pretty simple, but we've started to see other applications, so similar types of games being built both in-house as well as like on DevNet, by people, devs playing around. Those are just like kind of the basic, very first easy examples, and we're starting to see other more interesting ones being built by developers as well, like kind of moving into other types of things that are in addition to games. Like I think we have like an app that deals with medical data, and we're really exploring the design space there.
There's also some pretty cool ideas coming from people who have already developed apps for multiple different chains. So like there are clearly a number of different, like let's just say DeFi protocols that have deployed something on EVM chains and deployed something on SVM chains, and like we'll hopefully be able to like talk about this like very, very soon, like the example that I have specifically in mind. But like people are starting to realize that you can actually do some pretty innovative things if you use Fluent as like to develop like a new component that like kind of aggregates things in a pretty unique way. So it actually circumvents like a lot of other kind of like workarounds to the solution that they otherwise would have had done. Still very like clearly that sounds like still very abstract, and like hopefully over the next couple weeks and months we'll just be coming out with like more and more of these like case studies as they actually start to hit our DevNet and as we start to like lock in those partnerships from existing teams. So but yeah, we're seeing a lot of like cool like juices flowing. There was even one some people talking about leveraging like SVM, like gaming frameworks, and EVM gaming frameworks, and almost just like building experiences that encompass both of them. And that's still kind of like early exploration, but just like it starts to get the juices, at least like what we're seeing is it starts to get the juices flowing of what you can actually do with this stuff. You're like, oh wow, there's like there's a lot of really cool shit built for SVMs, a lot of really cool shit built for EVM. Let's just like take them both and then use them to build something really cool. So yeah, we're seeing a lot of that.
That's extremely exciting. As I can understand, I guess like you with this new design, right? Like it push a bit like blockchain to a new paradigm, let's say, where more things are way more are doable, let's say. So no, that's super interesting. Like this division of multiple components of the app, and then like using like the best job for the best tool for the job. I think like I take back one of your sentence here, but like that makes a lot of sense explained that way. So I remember when I posted my first thread about blended execution, many people asked what was the difference between like blended execution and, let's say, a multi-VM framework like Arbitrum Stylus, for example, which, if I'm not mistaken, is kinda doing the same thing. If you just like take the ID, which is like this WASM and the EVM. So like, how is your design different? Like what how do you compare with them? Like how blended execution is different? If you could give me a bit more explanation on that, I would appreciate.
Steph, you want me to go, or you want to go first? Okay. All right. So let me actually back up and walk through like the past like year or two very succinctly of like how we got here and how like these, why this like, I'll say multi VM problem is actually trying to be solved. Because we didn't really talk about that much in the beginning. So like clearly most of the EVM, most of the chains today, L2s, L1s, doesn't matter, are like EVM. And over the past, and that's proliferated, and it's been very easy for people to kind of like copy and paste that, and it's like kind of natural for like an early nascent industry. And it's like, okay, over the past year, we've started to see people want to do a lot more. You've probably heard of like some of these other VMs, like we were talking about in the beginning of the show, like MoveVM and SVM, etc. And so there's like, we didn't invent this problem to solve. The people have been trying to solve this problem over the past like year or two, which basically says, how do you get the best of both of these scenarios where you have like the EVM stuff and like all the ecosystem and tools and all the things we're talking about, and then like some of these newer VMs. And so the natural next step is like, let's try to squish them together somehow. And I think there's been a full spectrum of implementations like that range from like more or less clunky, but they all kind of fall into this like multi-VM category. So I would say like on the clunkier side, you can I'll try to like not get like technical with it. Like you can conceptualize it in some scenarios as like a third-party team saying, hey, I have this VM, let's just put it on that VM. And, like maybe it's like EVM on Solana or something like that. And they've literally like a third-party team came to like Solana and said like, let's just try to like run this VM over here and do the best we can to like make them interoperable. And we found those types of solutions to be the clunkiest, honestly, where like you have to switch wallets, you have to like bridge between different networks, switch tokens sometimes, like the contracts that we were talking about before, like cannot talk to each other. And so it's basically two networks. Like it feels more or less like two completely separate networks, right? So like that's kind of like the clunkier side of the spectrum. And then I think on like the not clunkier side of the spectrum, like the not clunky side of the spectrum, but still multi-VM is probably something like Stylus, where like the experience is pretty good. And they actually do like a pretty good job kind of like unifying things together. But I would still say that like any scenario where somebody is like running multiple different VMs ends up being suboptimal. And so that's why we've taken the approach of actually just what we like to think of as like blending these VMs and not actually running any of the other ones and just simulating them. And so the question is like, why? Like, why is that better? I'd probably say it comes down to like efficiency and extensibility. And they're kind of like interrelated. So the fact that the way we're supporting these other, I'll try to make this like ELI5. Okay, this is new terrain. The fact that we're supporting those other VMs via like precompiles, like smaller, more lightweight, efficient pieces of software than running a full VM makes it so it's much easier to ZK proof. So if you tried to actually ZK proof like literally execution environments with multiple different VMs, it would be much less efficient and costly. So that's one thing. That's the efficiency thing. Even if you were going to compare like 2 VM supported versus 2 VM supported. Then there's the extensibility part of it, where the fact that we have architected the system from the ground up to where all you need to do is add new precompiles, basically like add new low-level smart contracts to support new apps from different VMs. So let's just say it could be Move. It could be like, we're working on Fuel right now. It could be some new VM that somebody hasn't conceptualized yet and has some novel benefits in a year from now. But the point is like, because we're taking this approach, it's like actually very efficient and pretty, trivially extensible to add new ones going forward. So it kind of future proofs the system. And then in that state of things, let's just say we're not dealing with 3 apps from 3 VMs, but we're dealing with apps from 10 VMs or 15 VMs. Doesn't matter. It still adds trivial proving overhead. So it's still basically just as efficient to ZK proof. And I think everybody like has already bought into the fact that ZK is the future, and like that's where everything will head. So you want to design the system in a way that actually scales elegantly in that world, rather than just trying to literally add like I don't know what the other approach would be, like literally adding like 10 VMs into an execution environment and like trying to like make them all not feel so. I don't know how you would even ZK proof that, to be honest with you. So anyway, I'll stop there, see if that makes sense. You can unpack it further. Steph, feel free to shed more light too.
Yeah, I think no, you did a really great job of explaining that. But if I understand correctly, like if you're taking one of the alternate approaches, which is to not just simulate multiple VMs, but actually like fully run the different VMs, and you're putting that into like a ZK system, you need to individually prove, right? Like each different state transition function. So each different operation of the VM. So at the end of the day, it'll be like if you have 3 VMs supported, that's going to be 3x proving overhead. Whereas with Fluent Solution, you're just proving the low level RWASM VM, which encompasses the rest. So you're saving 3x on, an efficiency gains right there.
That was super clear. So yeah, I mean, like, if I have to sum up, like the main difference is probably like this concept of extensibility, which means that, let's say, at some point with this multi-VM, which is really like having those like multiple virtual machine like running like side by side, you won't be, or at least it will be very costly to add more virtual machine. While with blended execution, which only simulates and only have like a single virtual machine, like this design is extremely extensible, which means like if I want to add, let's say, 20 virtual machine in a world where we go crazy on alternative virtual machine, it's totally possible, right? So yeah, I think like we can clearly get the difference here. I think that the rest is probably design and it's going on like under the hood. But like I think like the competitive advantage, or at least that the compelling point of the blended execution design can clearly be seen that way.
Yeah, and just to add one more thing there, you can even go as far as imagining the addition of new VM targets to be basically permissionless. Like the fact that somebody can add their own support to the framework, which we really didn't talk about today, but being able to add their own support in a way that doesn't involve like Fluent Labs, I feel like is a really, really meaningful thing. And in fact, like that will be, if anybody saw our recent collaboration with Fuel, like we've done some of that initial like researching and proof of concept work just because it's such early days for us. And like, you know, we're in DevNet, so like things are shifting around and like it's not, you know, it's still kind of like we're still solidifying the foundation. But as we transition and get into like testnet and beyond, that interaction could have just been done by them. And like they probably will like work with us very closely and eventually kind of like maintain that themselves. And then, you know, future like VM teams can literally just come in to Fluent VM and just add something. And so then therefore like anybody who spins up uses our framework, which is called Fluent Base, to build new blended execution environments. Well, then they have a new VM to choose from, and they can either enable a bunch of them or they can just like hyper focus on a few. And so I feel like that it needs to be super extensible to even like be in that position to make it permissionless. And so I feel like that's a pretty like meaningful thing.
That's extremely interesting, like this notion of permissionless, the permissionless way of adding more and more virtual machines. So you just touched based on Fluent Base actually, and like if I remember correctly, you will have Fluent Layer 2, which will so blend the EVM, the SVM, and WASM, right? And you have like this Fluent Base, which is, I guess, like the stack that any developer can come and then like combine whichever virtual machine that they want, and then like if they want only 2, they can go for 2, let's say full and the SVM, and if they want to go for 10, they can go for 10, right?
Correct. So the way that Fluent Base works is like you can kind of think of Fluent Base versus Fluent is kind of like the OP stack versus Optimism. So Fluent Base is being used to build the Fluent L2, taking into account EVM, SVM, and WASM, like you said. But as a developer, as a blockchain developer, you could create a rollup of Validium, whatever construction you want, using the tools available in the Fluent Base SDK or the Fluent Base framework. What's interesting about it is that we're also, in addition to offering like, teams will be able to permissionlessly add VMs and developers will be able to mix and match between those VMs. That is also true of the other components of Fluent Base. So we've integrated with different sequencer solutions, different DA layer solutions. So you really have like full customizability in what you want to build. So that means you can build L2s, L3s, obviously full rollups in that they are using a base layer or a consensus and DA layer as where they settle, or you could also build Validiums and use external DA, like something like EigenDA. It's really up to the developer's desire at that point. In the future, though, we will, and this is like, the far future, after Fluent L2 mainnet becomes a reality and, things are stable and we've, really honed in on and, executed on just like the Fluent L2, we do have future plans to move into more of a proof aggregation system to enable L3s that settle to Fluent. And what that means more concretely is that even though you can use the Fluent-based framework to deploy wherever you want and build whatever you want, it will be advantageous to you if you want to build an L3 to settle on Fluent as an L2 using our proof aggregation network, because that way you have cheaper proving costs because you'll be sharing the proving with the other L3s that also take advantage of the system, but it also enables trust minimized composability between the different L3s that opt into the system. That's probably getting a little bit too technical for today, and it's also a very far future thing, but we'll have more education on that as we grow.
It's funny, there's even I was actually just thinking that wasn't too technical, but like it could very well get too technical, because we're actually there's a very like novel like construction that we're enabling that you can call L3s, but like actually aren't even blockchains, and that's a whole nother ball of wax that Rolf, we will probably have you like we'll of course be like, we'd love if you like explain Electrum 5 at some future state, but that is a little bit further away. Like we're super focused on the L2 and that's of course like already enough effort to like bootstrap and make sure it's successful.
That's super exciting, and yeah, for the L3, you can count on me. I will try my best to break it down in very simple words.
Thanks, bro.
No, guys. I think like it's a bit everything I had on my side. I think now we managed to keep it not that technical, which was the which was the purpose of this stream, I guess. I'm pretty happy with how it went. I think you guys did a very great job into just putting really simple words on this. It might be scary to see this blended execution word, but you did a very great job in putting very easy terms on it. So really appreciated, and I'm sure the audience and the chat will love it as well.
Bro, means a lot coming from you. You're the best in the game at doing that, man. And let me just say, like, your brand as somebody who like started in crypto, doing some similar, not like very broadly like similar things of like, hey, let me see if I can like take some of this complicated tech and like break it down in some way. Like I definitely did it for more of like a technical researcher kind of audience, but but I see like what you're doing, man, over the past year or so, and like, holy shit, it's just such a unique niche in the space. And I just think that people like you are going to be so crucial to actually onboarding like more people into this stuff, because people come in, they're confused as hell. So everybody who's listening to this, follow this man, Nayrolf, bro.
Thank you, Dino. That
thanks
means
for coming
a lot.
Yeah,
That's mean a lot.
I absolutely second that. Like also, Dino and I have similar backgrounds in like the research, like, content production kind of side of things. And like, yeah, you're doing incredible work. Just like, it's so hard to distill these things into simple terms sometimes. And like, you always do it in an elegant and fun way. So 100% match that sentiment.
Thank you, Steffi. That means a lot.
Mm.
All right. I think we can probably wrap up now. Right?
Sure. For me, it was perfect.
Steph, anything else for you?
No, that's it. Yeah, I guess, well, maybe one last thing. It's just that like, yeah, this stuff is really new, right? The notion of blended execution. Like, I think this is really like the very edge of what's happening in blockchain and like advanced technology, like in general. So yeah, it's like really is an honor to be able to do this kind of stuff with you and like try to build and like go in directions that have never been gone before. And so yeah, I just find it really, really fascinating to get to do this every day, and just want to share that.
If anyone else is listening and has more follow-up things that we need to break down, just ping us, respond to this thread, or respond to this like this stream post or something like that, because this was really fun, honestly. So thank you for coming on, man. Thanks for everyone who's still with us. Till next time.
Cheers, guys.